In this video, we're going to focus on how to complete the square to get a hyperbola in standard form and then identify all of the parts. We're going to add one more concept in. Now, for completing the square, it's going to be a little similar to how we did it with ellipses. Since you have two quadratic terms, we're going to have to complete the square twice. So let's try it in this problem. First thing I'm going to do is I'm going to see that my constant is already on the other side, and I'm going to pair up my like variables. So I'm going to have 5x squared minus 40x, then a minus 4y squared minus 16y equals 36. So I'm going to put the like variables next to each other, and that allows me to easily see the completing the square concept. What I'm going to do is factor out a 5 from the first two terms, so that way I can complete the square with our x variable. And so if I factor out that 5, like I said, I'm going to complete the square. So I'm going to leave my placeholder. So it's going to be x squared. It'd be minus 8x plus the placeholder for when I complete the square. Now for the other one, for the y variable, what you're going to do is factor out a negative. Now that should make sense because of the standard forms to your hyperbolas. It's either the x squared minus the y squared or the y squared minus the x squared. So you're going to want that negative. So we factor out a negative 4 and we set it up for completing the square at the same time. So y squared, now do be careful, since you take a negative out of this negative 16, it's going to become a positive. So plus 4y and our placeholder. Now we have two placeholders on the left, so to keep the equation balanced, I'm going to have to put the two placeholders on the right as well. So now we complete the square for it. Well, for the x, you're going to take half of negative 8 and square it. So that's negative 4 squared, which is 16. For the y variable, you're going to take half of 4 and square it. So that's 2 squared, which is 4. All right, so that means a 16 goes here and a 4 goes there. But those aren't the numbers that go on the right. You should know that by now with all the completing the scores you've been doing. For the first one, 5 times 16 is actually 80. So 80 goes here for it. And negative 4, remember it's a minus, so that's negative 4 times 4 is really negative 16. So now let's finish the completing the square process. We still have this 5 on the outside. We squared for this first parentheses a negative 4, so minus 4 goes on the inside. And then we have our minus 4 parentheses, and we take a look, what do we square to get this positive 4? We squared a positive 2, so then we're going to put a plus 2 here. And if I were to take 36 plus 80, and then plus a negative 16, that would equal 100. It's still not in standard form because standard form for a hyperbola is equal to 1. So what I'm going to do is I'm going to divide by this 100. And I'm going to do it to every term. So now the easy way I do it is I don't think about like simplifying a fraction. I just see, okay, 100 divided by 5 is 20. And so that means my 20 is going to be in the bottom because I took the bottom divided by the top. So it's going to be x minus 4 squared over 20. And you have minus, 100 divided by 4 is 25. Since I took the bottom divided by the top, 25 is going to go in the bottom. And that's y plus 2 squared. So there is my standard form for the hyperbola. That will allow me to find h, k, a, b, and c, which will then allow me to graph the entire thing and identify all the parts. So here we go. Let's start by identifying our h and our k, because that is our center. First, we can look at, well, since it's x squared term minus the y squared, that tells me that this is a horizontal hyperbola. So our H value we can see is 4, and our K value is -2, which means my center, the first thing I want to find, my center is located at the coordinate 4, -2. So let's do that. We're at 4, -2. There is my center. Then I find my vertices. To find the coordinate of the vertices, you can go to the formulas. That's fine, but understand it's going to be so easy if you get the concepts down. You're doing a horizontal. That's the transverse axis. It's horizontal, and what you're trying to look at is, okay, what's the formula for my vertices? Well, if you're going horizontal, it's left and right. So you go left and right, A units. So that means you're adding and subtracting from your X term, which is H. So H plus or minus A comma K is the formula. So that would be, I need to know A. So I can look here. A squared is 20. So A is the square root of 20 for it, which is approximately 4.5. You can see B squared is 25. So B is 5. I have C squared is A squared plus B squared. So C squared is 45. So C is the square root of 45, which is going to be approximately 6.7. Now, I'm going to go ahead and use the decimals for this. There's more decimals here, square root of 20 and square root of 45, to make our lives a little bit easier and to not confuse you with all the radicals. So let's start. H plus or minus A comma K. Now I'm going to go ahead and graph, and then I'll use the formula. Since it's a horizontal transverse axis, I'm going to go to the right and the left 4.5 units. So 1, 2, 3, 4.5, and there is one of the vertices. Go to left, 1, 2, 3, 4.5, and there is one of the other vertices for it. That's simple. You can rely on the formula. That's fine. You have 4 plus or minus 4.5 comma -2. So if you were to add 4.5, you would get 8.5. So 8.5 -2. If you were to subtract 4.5, you would get -0.5. So -0.5, -2. And so there's your vertices. Next thing I need to do is I need to find the coordinate of my foci for this. So same idea, it's C units from the center on the transverse axis. So that's H plus or minus C comma K. Now, since I know the square root of 45 is 6.7, I can go to the right. 6.7. 1, 2, 3, 4, 5, 6.7, a little over halfway. I'm going to put an F for foci. Go to left, 1, 2, 3, 4, 5, 6.7. Going to put an F next to that for foci. Use the formula. Go ahead. You have 4 plus or minus 6.7, comma, -2. 4 plus 6.7 would be 10.7, -2. And we can see that's where I'm at. If I were to do 4 minus 6.7, it'd be -2.7, comma, -2. And we can see that's where I'm at as well. And the last thing we need to figure out when we're graphing is what are the slopes of the asymptotes. And since our A value here is left or right movement, that means it is rise over run. Our A is a run. So it's going to be plus or minus B over A. So then my slope is going to be plus or minus 5 over, we can just leave it as 4.5, and that's fine. And so now let's go to our graph. Let's use that slope. So we're going to go up 1, 2, 3, 4, 5, and to the right 4.5. I'm going to go down 1, 2, 3, 4, 5, and to the left 4.5. Then I'm going to do the negative slope. Down 5, right 4.5, and we have up 5, left 4.5. And now I graph with my dashed lines to create the asymptotes. And so come down and through. I'm going to come up and through and make sure you extend them across the entire grid. So let's go ahead and do that. And I'm going to come up so I can extend it across the entire grid. Make sure I go to the dot. So there we go. Again, let's change the color so we can distinguish between this and the graph of our actual asymptote. And now we graph. So we start at a vertex. Again, you want to approach the asymptotes but never cross them. So come up with a curve and approach the asymptote across the entire grid but never touch. Come up with a curve, approach but never touch. Come up with a curve, approach but never touch. And so there is the graph of our horizontal hyperbola. So we again practice our formulas, but mainly what I want you to get is the concept of completing the square to get a hyperbola in standard form. So I hope you find this video helpful, and we have one more video left in this series.